Isn't that incredible? He'd had that much impact. He had done for biology what Newton did for the physical sciences. Both of them were strong creationists. Both of them did their work because they were creationists. To say that if Isaac Newton lived today, he'd be an evolutionist, or Linnaeus would be, well, I'm lost for words. And Fuller says, both these scientists exemplified a synergy, between cutting-edge science and enlightened Christianity. And science continued to be indebted to creationism in the 19th century. So he's talking about how long this influence of creationism lasted, Fuller is, and he's saying that both Linnaeus and Newton married together cutting-edge science and enlightened Christianity, and that's why they were so successful. Fuller still. Thus, while Darwin denied that biological species were either specially created, immutable, or intelligently designed, he nevertheless retained Linnaeus's binomial classification of species. So you see, he worked with what a creationist had done, but sought to eliminate the very basis on which that work had been done. So, just to repeat, both Ray and Linnaeus were special creationists. They believed that God had created organisms in specific groups called kinds in the Bible, and it was special creationism that gave the impetus which led to modern genetics. We're getting there, we're getting to modern genetics, but we haven't quite got there yet. This is an important point. Linnaeus originally believed that species could not change. Now, species is actually something that's very difficult to define. You need a different definition, for example, for bacteria than you do for animals. It's not an easy thing to define, but however they were defining it then, Linnaeus originally believed, as did a lot of other Christians, that species could not change in any way. But he changed his mind, and this wasn't, the more one reads up on this, I mean, I'm still learning a lot about this, and I've only just realised, I thought he came to that conclusion later in his life. But from what I've read recently, I think that isn't the case, that he quite early on came to realise that this wasn't totally true, because viable hybrid forms of plants could be produced. Hybridisation was of great interest to them, where they cross-fertilised, particularly it is easy to do in plants, of course, much less easy in animals to bring it about, well, very difficult in animals, but in plants you can get these hybrid specimens. So what Linnaeus came to believe was that there was some limited flexibility within the original created kinds, so that, for example, you could produce a hybrid which was slightly different from the parent, the two original parent plants, and which bred true, which wasn't sterile. Hybrids often are sterile, but Linnaeus realised that sometimes they weren't. And so he changed his mind. And he came to believe that God had created the kinds with the potential for limited change. They were still essentially the same plant, but rather than at the level of the species, he took it back to the level of the genus and even to higher levels in some plant instances. But they are still basically the same kind, but he was discovering that there was a potential for change. And I'm stressing this because this actually is the standard position held by many creationists today. It dates back as far as Linnaeus in the 18th century. This is the fruitful position, the one that led on to modern genetics, that the original kinds were stable, but within the kinds there was flexibility and potential for variation. Very definite boundaries to it, but not completely static, as some creationists did say. And Linnaeus felt he had proved that to be wrong, and he was able to change his mind about it. And so now we move on another 100 years and come to Gregor Mendel, who is known as the father of modern genetics. He was a monk. Now, you probably know the story of Mendel, how he worked with peas, doing, again, he was very interested in hybridization, did a lot of hybridizing type crosses. He applied statistics. He handled it very mathematically. He developed statistical relationships from his results, of how he published his work, of how it was not acknowledged, and he died without seeing any of the fame that subsequently came to him. So the picture on the left is a memorial to him in the place where he lived, which I think is in the Czech Republic. It's one of those parts of the world that changes, but it's that kind of a area. That he died having no idea that there would be big public memorials to him and that he would be so famous. As you can see, he was a contemporary of Charles Darwin, a monk living and working in a monastery. Very different background to Charles Darwin, who obviously was very moneyed. He never had to work for a living. Darwin, he was not a professional scientist. He was able to live on inherited wealth, and Mendel was in such a different position. But Mendel was another special creationist who built directly on the work of Linnaeus. He picked up the interest in hybrids that Linnaeus had. He was seeking to understand, as Linnaeus was as well, how inheritance worked to produce both stability and variety. That's an interesting question, isn't it? Because God had created in these different kinds, and yet what we know there is a lot of variety. What was the actual mechanism of inheritance that made this possible? And as I've said, he believed the problem could be investigated mathematically, and he did apply maths to it, statistics to it. And this is what has not been recognized until very recently. His work was done in deliberate opposition to Darwinism. He did not believe in descent with modification. He was actively working to show that it wasn't true. Now, some people think that he specifically only started his experiments after Origin of Species was published. It's more likely he started them before. But you've got to remember that Origin of Species the picture we often have is not the real one. There was lots of debate going on beforehand. The book coming out and people like Huxley promoting it brought about this big change in public opinion, but the ideas were there before. So there was always, once we got into the 19th century, the conflict between the people who believed in design and in creation and those who were wishing to believe in a form of evolution but felt that they didn't have a mechanism for it. What Darwin seemed to put forward was a mechanism for it. But what is absolutely plain is that Mendel, this is completely plain from his papers, that he was opposed to Darwinism. He was actually another special creationist, as you would expect from a monk living at that time. What he actually showed was that when a new variety appeared, the cause could, I'm using the words genes and genome here in a modern sense, which obviously he wouldn't have done. It's hard to get back into the mindset of how it was in the 19th century, isn't it? So I'm using those words. You have to forgive me. It's not, if you're purist, it's not strictly right, but I hope you will understand what I'm saying. The cause would be a new combination of genes that had always been present. Nothing new had been added to the genome. Now, Darwin knew that hybrids were not good news for him if this was all that was happening. He has a chapter on it in Origin of Species. He deals with this question and of this kind of question, that if you get change, but in the way that nothing new has been added, then his sort of evolution cannot happen. Because Darwinism requires that new varieties should have new genetic causes, whereas that was not what Mendel's experiments showed. They showed that, yes, you could combine hybrids to produce a lot of variety in the next generation, and new tendencies could appear that look new to you, but then Mendel demonstrated that this was simply a re-emergence of a genetic factor. He didn't know what it was, but of some factor being passed down, had re-emerged, and it had been there all the time. That's why Mendelism was in such conflict with Darwinism.